A helicopter hovers low over a quiet suburban neighborhood outside Brisbane, and for 11 seconds nothing happens except the heavy thump of rotors and the tick of a Queensland summer. Then a technician crouching at the tree line lifts a gloved hand and says one word into his radio: confirmed. What he has just confirmed is not a bomb, not a body, not a wildfire. It is a mound of reddish soil no bigger than a dinner plate, sitting beside a child's swing set. Within 4 hours, the street will be cordoned off. Within 4 days, 300 properties across the suburb will be inspected. Within 4 months, the Australian government will have spent more money defending this single postcode than most countries spend defending an entire coastline from invasion. The enemy is roughly 5 millimeters long. Its name is Solenopsis invicta, the red imported fire ant, and Australia has now spent more than 1 billion Australian dollars trying to make sure it never becomes permanent. The question is not whether Australia is serious. The question is whether being serious is enough. Can Australia actually win? Australia has a fraught history with invasive species, so it's no surprise that an insect the size of a grain of rice could trigger a billion-dollar response. Cane toads, European rabbits, and feral cats, which kill over 1 billion native animals annually, have taught Australians that small mistakes with foreign species rarely stay small. When fire ants were detected at the port of Brisbane in 2001, likely stowaways in South American cargo, authorities responded immediately. Containment seemed to work for a few years, but eventually the maps stopped matching reality. By the early 2020s, the infestation had spread across more than 700,000 hectares, with modeling warning that an unchecked invasion could ultimately cost the country over $200 billion. That staggering projection is why thousands of people, biosecurity Queensland officers, sero-entomologists, and farmers reporting suspicious mounds, are now waging the largest eradication campaign ever attempted against an invasive ant species anywhere in the world. Backed by a massive $1.2 billion government funding package, this isn't a single hero's mission. It's a nation running an experiment it cannot afford to lose against an adversary unlike anything it has faced before. The stakes reach far beyond any one backyard. Cattle producers worry about newborn calves, which can be blinded or killed by mass stinging in their first vulnerable hours on the ground. Queensland's turf and horticulture industries face crippling losses if fire ants ever establish in major growing regions. And for outdoor communities, the danger is personal rather than statistical. A single disturbed nest can deliver hundreds of stings in seconds, and for a small number of people, those stings escalate into anaphylaxis. What began as a containment exercise around one port has become something that touches ranchers, schoolyards, and back gardens alike, which is exactly why the campaign keeps expanding. Senior biosecurity officer Sarah Mitchell had spent years on the front lines of Australia's fire ant campaign, and she thought she understood her opponent. Beta colony, monitor, confirm it's dead, move on. Then, after catastrophic flooding swept southeast Queensland, she returned to a zone her team had cleared and certified fire ant-free 18 months earlier. New mounds were rising over 2 kilometers from the nearest historical nest, in soil that had never tested positive. She first suspected a mapping error, then a missed nest, but neither explanation fit. The new colonies traced the exact path floodwater had taken through old drainage lines. The flood hadn't destroyed the invasion, it had relocated it. That observation cracked open a question American researchers had studied for decades. What happens to a fire ant colony when its ground floods? Instead of collapsing, colonies do something remarkable. Worker ants link their bodies using specialized claws and water-repellent hairs to form a living raft, sealing the queen and brood safely inside. These rafts can drift for days before reaching land, where the ants simply disembark and start a new colony. The disaster that should have wiped out a fragile insect population was actually one of its most efficient tools for spreading. Mitchell's cleared zone hadn't failed. It had been reseeded mid-flood by a mechanism no one had been trained to look for. Standing at the edge of that reseeded ground, Mitchell reflected on how central flooding is to this region's identity. Southeast Queensland had flooded disastrously in 1974, 2011, and 2022, each time reshaping rivers and forcing communities to rebuild. Flood recovery here had always meant clearing debris and drying out homes, never checking whether the water itself had delivered a new invasive species to the back fence. This realization forced the campaign to rewrite its entire model of risk. The weather pattern that defines the region had just revealed itself as the ants' most effective delivery system. If floodwater could carry colonies for kilometers in a single event, an uncomfortable question followed. How many other colonies had made that same journey during past flood seasons, quietly establishing themselves in ground no survey team had thought to check? Southeast Queensland flooded often, and fire ants had been established there for more than 2 decades. Suddenly, the campaign's entire premise was in doubt. Australia wasn't just fighting one expanding infestation. It might be chasing an unknown number of independent, undetected footholds scattered across a landscape too vast to search inch by inch. The opponent wasn't a single target, it was many, and each one stayed invisible until the moment it wasn't. Reproduction made the math worse before it got any better. A single mature colony can hold up to 200,000 ants and multiple queens, each capable of laying as many as 800 eggs a day. Destroy the visible mound and workers can relocate the queen to a new chamber within hours, a process called colony budding. Winged virgin queens can also take flight during nuptial swarms, riding wind currents more than 8 kilometers before founding a colony from nothing. Every method Australia used to fight the ants seemed to reveal a second, hidden method the ants used to survive it. Bait a colony, and it splits. Flood a colony, and it sails. Track a queen, and 100 more take to the sky behind her. For the first time, the campaign's leadership had to admit they weren't fighting an insect. They were fighting an adaptive system that treated destruction as an opportunity to relocate. And if the ants could outmaneuver eradication this consistently, the campaign needed something it did not yet have, an ally that didn't answer to a budget. For a while, that absence felt like the story's real ending. Mitchell remembers sitting through a briefing where the modeling team admitted, carefully, that treatment alone might never fully catch up to the ants' reproductive rate, not because the poison didn't work, but because there was simply too much ground and too many hidden queens for any survey crew to cover in time. Then the monitoring data changed the conversation. It found one, almost by accident, in a set of long-term monitoring plots nobody expected to matter. In certain untreated bushland sites, fire ant colony density was quietly falling, with no bait drop, no chemical treatment, no human intervention of any kind on record. Entomologists initially suspected disease. What the field data actually showed was walking around on 8 legs, 6 legs, and 4. Meat ants, an aggressive native species already common across the country, were documented contesting fire ant colonies at shared foraging boundaries. Utilizing their massive purplish-red heads and powerful non-venomous mandibles, they launched relentless turf wars, overwhelming smaller fire ant nests through sheer numbers and coordinated swarm tactics. Meanwhile, solitary wolf spiders operated like textbook ambush predators. Camouflaged perfectly against the leaf litter, they were filmed staking out burrow entrances and executing lightning-fast strikes to snatch up unsuspecting foraging workers. Even more surprising was the structural demolition led by water rats, or racali. These semi-aquatic natives, easily recognized by their thick, water-resistant fur and distinct white-tipped tails, were caught on camera digging directly into the heart of fire ant mounds. Armed with dense, calloused paw pads and heavy fur, they systematically excavated the nests to feast on both ants and protein-rich larvae, completely undeterred by stings that would send most mammals running. Beneath the brush, skinks darted like quicksilver through the debris, while agamid lizards sat motionless on branches, their whip-fast tongues snapping up fire ants like tactical vacuums. Along with ground-foraging birds, they all showed the same pattern: more fire ants in their diet in infested zones than anywhere else. Mitchell was sent to verify one of these sites herself, a patch of remnant bushland where colony counts had fallen nearly 40% over 18 months with no recorded treatment. She spent 3 nights there with infrared cameras, watching water rats systematically working the edges of fire ant mounds, undisturbed by the ants swarming over their forepaws. It was the first time in her career she had watched a native animal treat this invader as nothing more than dinner. She radioed the finding in the same flat, procedural tone she used for every field report. Privately, it was the closest she had come to feeling like the campaign might actually be gaining ground. For a campaign that had spent 2 decades absorbing bad news, This felt like the first real reinforcement. Australia's own wildlife, forged by tens of millions of years of isolation, appeared to be doing something no scientist had engineered and no government had funded, fighting back on its own. Just an ecosystem doing, for free, something the world's most expensive eradication campaign was struggling to do at scale. For a moment, the story seemed ready to resolve itself. Maybe Australia didn't need to defeat 200,000 ants at a time. Maybe it just needed to give its own wildlife room to work. That hope did not survive the next round of fieldwork. When researchers actually dissected what predators were eating, the pattern that emerged was almost entirely surface level. Meat ants, wolf spiders, water rats, and lizards were targeting foraging worker ants moving above ground. None of them were reaching the queens. A fire ant queen spends nearly her entire life sealed in a protected underground chamber, fed and defended by workers, almost never exposed to a predator's teeth or claws. A colony can lose enormous numbers of foragers to predation and barely notice, because a single surviving queen can replace that loss with a few days of egg laying. Native predators were not attacking the invasion's reproductive engine. They were trimming its outer edges, while the core kept running, untouched, beneath the soil. It was the cruelest reversal yet. Nature hadn't defeated the fire ants. It had, at best, bought a little time it had no way of spending on its own. And if the ecosystem's best defenders couldn't reach the one part of the colony that actually mattered, the campaign was back to a question it thought it had already answered. What, exactly, could reach the queen? That question forced Australia's strategy to evolve again, opening a second front fought at a different scale. Environmental DNA sampling from soil and waterways let researchers detect a colony's genetic trace before any mound broke the surface, offering hope of finding nests before they could bud or flood raft away. But eDNA could confirm a colony had been somewhere, not pinpoint exactly where a queen was hiding now. Thermal drones scanned vast tracts of land, far faster than any human crew, until researchers realized dense vegetation and overlapping wildlife heat signatures could mask a colony as easily as reveal one. Genetic sequencing of captured queens traced fresh incursions versus descendants of known nests, turning scattered detections into a map of lineage and spread, though that map only showed where the ants had been, never where they were heading. Parasitic phorid flies, introduced from South America to lay eggs inside fire ant workers and disrupt their foraging, offered a genuinely promising biological check that worked with the ecosystem rather than against it, though even cautious researchers admit it's a brake on the invasion, not a cure. Every tool delivered an advantage. Every tool also exposed a new gap. Even artificial intelligence, brought in to fuse drone footage, eDNA hits, and colony records into predictive outbreak maps, hit the same wall. Models were only as good as their data, and fire ants generated new dispersal events by flood, flight, and budding, faster than any model could be retrained. The war had stopped being about killing mounds one at a time. It had become a contest of adaptation speed, a species refining survival across a handful of generations versus a nation refining detection through research cycles spanning years. Mitchell felt that asymmetry directly. Years after her first flood discovery, she returned to a different treatment zone, this one equipped with drone surveillance, eDNA stations, and a biological control trial running quietly in the background. On paper, the most sophisticated defense the campaign had ever deployed. Yet walking the perimeter, she found a Queen's dispersal trail the technology had missed. A handful of workers moving purposefully toward undisturbed ground the drones had scanned and cleared just days earlier. The tools were better. The advantage was real. But generation after generation, the ants kept finding the seams. Zoom out far enough, and Australia's fire ant war stops looking like an isolated national emergency and starts looking like a preview of something much larger. For most of evolutionary history, oceans and deserts limited how fast species could move between continents. Global trade shattered that barrier within a couple of centuries, and in the last 50 years alone, container shipping and international agriculture have accelerated the spread of insects, pathogens, and animals to a pace evolution never anticipated. Climate-driven extreme weather, the same flooding that first betrayed Mitchell's cleared treatment zone, is only making that movement faster and harder to predict. Fire ants have already invaded the southern United States, large parts of China, Taiwan, and the Caribbean, and are now expanding through parts of Europe, confirmed establishing populations in Sicily in 2023. Every nation facing this insect is effectively running its own version of the experiment currently unfolding across Queensland, at different scales, with different budgets, and, so far, no country has produced a definitive answer. In the United States, where fire ants have been established since the 1930s and now cost an estimated $6 billion a year in medical treatment, property damage, and agricultural losses, full eradication was abandoned decades ago in favor of permanent management. Australia is the first nation with the wealth, the biosecurity infrastructure, and the political will to attempt something the rest of the world quietly decided was impossible. That is what makes Queensland's paddocks and suburban streets matter so far beyond their own borders. If eradication can work anywhere, the evidence will come from here first. Some researchers believe eradication remains biologically achievable if surveillance and biological control can finally outpace the ants' reproductive rate. Others argue that once an invasive species reaches this level of establishment across this much territory, true eradication may be a goal no biosecurity system, however well-funded, has ever actually achieved against an opponent this adaptable. Both camps are looking at the same data. Neither can yet prove the other wrong. Nobody watching this unfold yet knows which future Australia is walking toward. Which brings the story back to where it started. Australia has already spent more than $1 billion fighting an insect most of its citizens will never see up close. And Sarah Mitchell still returns to old treatment zones after every major flood, checking ground that was supposed to be clear, because in this war, clear is never permanent. It is only temporary, only until the next flood, the next queen, the next colony nobody has found yet. Somewhere in southeast Queensland, a detection dog is working a fence line, a drone is charging for tomorrow's flight, and underground, in a chamber no camera has ever filmed, a queen is laying more eggs indifferent to the $1 billion arrayed against her. Whether Australia becomes the first nation in history to permanently defeat an established fire ant population, or whether it becomes the clearest proof yet that some invasions can only be managed and never fully undone, the answer has not been written. If you want to be there when the next chapter breaks, when the next flood hits, or the next colony surfaces, or the next reversal rewrites everything scientists thought they understood, subscribe to our channel, because this war is still being fought, one queen at a time, and so is this story.